Welcome to Science to Sleep By. Tonight's journey takes you deep into the quiet, gentle corners of cosmic discovery, places where the universe speaks softly, and where science becomes a calm, drifting companion. As the world outside winds down and your thoughts begin to settle, we're going to explore one of the most fascinating and misunderstood visitors ever detected passing through our solar system, 3I Atlas. This is not a loud mystery or a sensational headline. It is a subtle, silent traveler from the deep interstellar dark, moving with the grace of an old cosmic story and carrying the whispers of distant suns. Tonight, we follow its path, uncover what NASA has learned, and gently reveal what they should have told you long before now. So settle in, breathe deeply, and let the science guide you toward calmness, curiosity, and sleep. When 3I Atlas drifted quietly into the awareness of astronomers, it did so without the explosive media surge that surrounded earlier interstellar discoveries. Unlike Oumuamua, which sparked debates across the world, or the hyperactive comet 2I Borisov, which captured public fascination with its brilliant tail, 3I Atlas passed through a quieter, softer corridor of attention. Yet its importance was no less profound. In many ways, its modest introduction to Earth's telescopes makes it even more intriguing, because it represents a class of objects that likely pass through our solar neighborhood more frequently than we ever realize. The universe rarely announces its arrivals dramatically. Instead, it lets us uncover them through moments of patient observation, soft data signals, and the silent curve of motion traced across the sky. That quietness is what makes 3I Atlas such a perfect story for a science to sleep by exploration. Because everything about it feels gentle, subtle, and deeply patient, as if the object itself were simply gliding past us without urgency or intention. 3I Atlas was discovered in 2019 by the Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to detect objects that could pose a danger to Earth. The irony is that this particular object, despite being flagged by a system built to warn us of threats, posed none at all. From the moment its orbit was calculated, astronomers understood that it was moving through the solar system on a hyperbolic trajectory, a mathematical signature that means it was not bound to the sun's gravity. It was passing through, not orbiting. It came from the deep dark between the stars, and it would return there once its brief solar encounter concluded. You can imagine this path like a long and graceful arc, shallow and deliberate, carved not by a planet or a moon or any familiar gravitational partner, but by the slow and ancient momentum of galactic drift. Objects like 3I Atlas are not part of our solar system's family. They are distant wanderers, running on the momentum of eons, shaped by no single world, but by a vast and wandering journey through the Milky Way. NASA did report that 3I Atlas was likely the third interstellar object ever confirmed, but unlike previous discoveries, there was little public excitement. This wasn't due to lack of scientific significance. Instead, it was the simple fact that the object was faint, fragile, and short-lived. By the time astronomers tracked it in detail, it was already beginning to break apart. In many ways, 3I Atlas felt like a whisper compared to the cosmic storms of larger and more dramatic visitors. It wasn't designed to impress the human eye or ignite a global debate, but in its quiet fading, it told a story of age, fragility, and the natural erosion that comes from drifting for perhaps hundreds of millions of years through cold starlight and cosmic dust. NASA's announcements were accurate, but they were minimal. They explained what it was, provided orbital elements, shared a few spectral observations, and confirmed its interstellar nature. What they didn't emphasize is how remarkable it is that Earth, a small world orbiting an average star in a spiral arm of the Milky Way, is now able to detect objects from other planetary systems passing by. The discovery of 3I Atlas should have been framed as a quiet triumph of human technology, patience, and curiosity. It should have been described not just as a distant fragment from interstellar space, but as a sign that the boundary between solar system objects and interstellar wanderers is becoming more transparent. Our instruments are improving. Our awareness is widening. The universe is revealing more of its hidden travelers, and 3I Atlas is one of them. This object is important because it represents something incredibly rare in astronomical history. For most of human existence, we assume that the objects traveling through the solar system were born here, shaped by our sun, sculpted by the local gravitational environment. But now, within a short span of time, we have seen several visitors whose origins lie far beyond our celestial neighborhood. Each one teaches us something different about the environments in which they form. 3I Atlas, small and fading, may have come from a region where comets form differently, where radiation pressure and stellar winds condition material in ways we are only beginning to understand. Its unusual structure, its delicate composition, and its rapid disintegration all point to a life spent wandering without the protection of a star, exposed to the slow-burning forces of interstellar space. For a U.S. audience, NASA's quiet handling of the event makes the story even more compelling. In an age where scientific news often competes with louder, faster content, 3I Atlas slipped beneath the surface, not because it lacked meaning, but because it required patience to appreciate. It's the kind of discovery that rewards reflection, the kind that invites you to imagine just how many objects like it might be drifting through the galaxy unnoticed. It invites you to picture a vast ocean of material floating between the stars, remnants of other solar systems, other worlds, other cosmic beginnings. These objects are not dramatic intruders. They are soft, ancient travelers. And 3I Atlas is a reminder that the universe is filled with subtle wonders that don't always seek our attention. The interstellar visitor few people heard about deserves a place in our understanding of the cosmos, because it shows that the Milky Way is more interconnected than we once believed. It shows that material drifts between star systems quietly and continuously, forming a slow exchange of cosmic history that spans millions of years. It shows that our technological ability to detect these visitors has reached a level where even faint, fragile wanderers can be observed before they fade back into the dark. And it shows that sometimes, the most important discoveries are not the loudest ones, but the ones that pass by gently, asking only that we notice them before they are gone. When astronomers first traced the trajectory of 3I Atlas, they saw something unmistakable, something that quietly but firmly separated it from every ordinary comet, asteroid, or icy remnant bound to our sun. It was the trajectory of a visitor with no home in the solar system, no closed orbit, no looping path, no gravitational anchor tying it to the familiar celestial motions that have shaped our space for billions of years. Instead, its path was open, hyperbolic, and drifting inward from a direction that hinted at a history far older and far more distant than any planetary body we typically observe. The stillness of its approach, the softness of its brightness, and the gentle sweep of its curve across the night sky made the arrival of 3I Atlas feel less like a dramatic event, and more like an ancient whisper from the galactic dark. To understand its approach is to imagine the Milky Way not as a solid, structured place, but as a grand ocean in which countless fragments drift over millions of years. Some of these fragments are born in the chaotic outskirts of young star systems. Others are cast out by gravitational disturbances, planetary migrations, or the long-term reshaping of distant suns. 3I Atlas is believed to have begun its journey in one of these environments. Long before it glided toward our sun, it may have circled another star, perhaps one much unlike our own. It may have formed in a disk of primordial dust and ice orbiting a sun that has since moved far across the galaxy. It may have been part of a cluster where multiple stars were born together. Or it may have been gently pushed away by a passing stellar breeze, caught in the slow but persistent tidal forces that sculpt the motions of everything in our galaxy. Whatever its origin, it drifted for a timescale far beyond human imagination, moving in silence through regions of space where no warmth shines and no winds blow. When NASA reconstructed its inbound motion, they noted the modest but clear excess of velocity, the additional speed that made it impossible for the sun to capture it. This is the quiet signature of interstellar provenance, a clue written not in dramatic events, but in the delicate mathematics of celestial motion. It reveals that 3I Atlas had been coasting for eons, its velocity shaped not by any recent encounter, In simpler terms, it was a mystery wrapped in contradictions, part comet, part asteroid, part something new. The surface chemistry hinted at both organic and metallic signatures, the light behavior suggested complex layering, and the internal structure defied straightforward classification. It wasn't just a rock or a ball of ice, it was a cosmic survivor, shaped by forces from beyond our solar experience. To the scientists studying 3I Atlas, the object became a mirror of the unknown, a symbol of how little we truly understand about the architecture of other star systems. Every pixel of those images, every spectral peak and thermal anomaly, whispered of a place we have never seen, a cradle of elements and processes beyond the reach of our telescopes. The anatomy of this interstellar mystery was not merely about what it was, but about what it suggested: that the universe is capable of building worlds, objects, and phenomena far stranger, far more intricate than anything our imagination has yet dared to champion. The early analyses of 3I Atlas were presented to the international astronomical community. The first reaction was cautious intrigue. Here was an object that appeared, at first glance, to behave like a comet, but refused to conform to the physics that defined one. For decades, comets have been the storytellers of our solar system, ancient wanderers of ice and dust that carry the frozen remnants of its birth. They warm as they approach the sun, releasing jets of vapor that sculpt bright tails visible even from Earth. Yet 3I Atlas seemed to disobey those rules. The official NASA images and accompanying data revealed a visitor that sat somewhere in the gray space between the known and the unexplainable, prompting one researcher to call it a comet in name, but not in nature. This sentiment echoed through observatories across the globe. As teams struggled to define exactly what this object was, the first indicator that something was unusual came from its coma, the faint envelope of gas and dust that typically forms when a comet warms. In the high-resolution NASA images, 3I Atlas displayed an incredibly thin, almost transparent haze around it. The coma was so faint that some instruments barely detected it. In comparison, 2I Borisov had produced a dramatic tail and bright halo, even at similar distances from the Sun. This discrepancy confused scientists. If 3I Atlas was made of the same volatile ices as known comets, it should have erupted with visible outgassing activity. Instead, it remained eerily subdued, almost as though it was coated in a shell that resisted the sun's heat. The few jets that did emerge came from scattered points across the surface and seemed erratic in both strength and timing. Unlike the predictable patterns usually observed, the object's rotation only deepened the puzzle. By tracking changes in brightness, NASA was able to model its spin rate, but the results didn't add up cleanly. The light variations were inconsistent, suggesting that 3I Atlas was not spinning as a single solid body, but possibly wobbling like a fragment with uneven mass distribution. Some sections of the surface reflected sunlight sharply, producing short bursts of brilliance, while others remained stubbornly dark. These rapid changes hinted at irregular topography, perhaps jagged ridges, sharp cliffs, or deep fissures. But they also suggested a surface composition that responded differently to light, as though certain materials were crystalline or metallic, while others were matte and porous. No comet ever studied had exhibited such a complex combination of reflective behavior. Spectroscopy, the method of splitting light into its chemical components, provided the most startling evidence that 3I Atlas might not be a comet in the traditional sense. The data showed traces of carbon and oxygen, but not in the usual molecular configurations found in water, ice, or carbon monoxide. Instead, there were exotic compounds with spectral fingerprints matching neither standard cometary ices nor known minerals. Some features suggested hydrocarbons that had been altered by intense cosmic radiation, forming complex molecules similar to tholins, the reddish substances that color Pluto and Titan. But even those comparisons fell short. The chemical readings hinted at additional elements, possibly heavy metals embedded in the outer crust, which would be highly unusual for a comet. These metals could have come from the object's birthplace, a region near a dense stellar nursery where radiation and shockwaves from nearby supernova enriched the local material. If true, then 3I Atlas was a product of an entirely different kind of solar system, one where the ingredients of planets and comets were mixed in unfamiliar ways. The mystery deepened further when scientists analyzed its albedo, or reflectivity. Comets are generally dark. Their surfaces are coated with carbon-rich dust that absorbs most sunlight. Yet the new NASA imagery showed that portions of 3I Atlas gleamed like glass. In visible light, some patches reflected up to 5 times more sunlight than the surrounding material. This disparity created strange glints, as if parts of the surface were polished smooth by unknown processes. One theory proposed that these areas were composed of silicate or metallic glass, formed when the object passed close to a star and experienced intense heating that melted and refroze its crust. Another hypothesis suggested that micrometeorite impacts during its journey through interstellar space had created thin, reflective veneers on its surface. Both explanations carried enormous implications about the environments 3I Atlas might have encountered before reaching us. What also puzzled scientists was the object's resilience. Most comets fragment when they experience thermal stress near a star, especially if they are structurally weak. 3I Atlas, however, remained intact. Despite passing within a distance where solar radiation could have torn it apart, it showed no signs of significant disintegration. This durability led some researchers to suggest that it might contain a denser core, perhaps metallic or silicate rather than icy. If that were true, then 3I Atlas was closer in composition to an asteroid than a comet, yet its faint outgassing betrayed the presence of volatile materials. It was, quite literally, something in between a hybrid of rock and ice, behaving like neither but embodying traits of both. The shape, too, resisted simple classification. Early radar models, combined with the visual data, hinted that the object might be elongated, possibly even bifurcated, like a contact binary, 2 lobes joined together by gravity. Such shapes are not uncommon among comets, but the angles of reflection suggested something stranger. The larger lobe appeared smoother, while the smaller one exhibited sharp, angular facets that caught sunlight like mirrors. It was as if the object's halves had different compositions, or had formed under separate conditions, before fusing together in the past. If 3I Atlas was indeed a binary object, it might represent a collision between 2 interstellar fragments from the same ancient system, a frozen monument to a cosmic accident billions of years old. As NASA's teams continued analyzing the high-resolution images, more subtle features emerged. Tiny streaks of vapor venting from microfractures hinted at trapped gases being released from within, yet the rate was inconsistent with solar heating alone. Some of the vents appeared to ignite suddenly and fade within minutes, suggesting internal pressures fluctuating without external triggers. This unpredictability defied standard cometary models, where outgassing is largely driven by the sun's proximity. The erratic bursts seemed almost mechanical in their rhythm, though no artificial explanation was seriously entertained. The data merely underscored that 3I Atlas was operating on principles not fully understood. The debate within NASA and the wider scientific community became a philosophical one as much as an astrophysical puzzle. How do we classify something that behaves partially like a comet, but refuses to adhere to the rules that define one? Was 3I Atlas the first example of a new class of interstellar objects, bodies forged under different stellar chemistries, carrying properties unknown to our solar system? Some proposed calling it a hybrid interstellar fragment, while others argued for restraint, preferring to keep the label comet until its true nature could be confirmed. Yet even among the most conservative voices, there was an unspoken acknowledgement that 3I Atlas had blurred a line that once seemed clear. It reminded humanity that cosmic categories are human inventions useful for understanding, but powerless against the universe's tendency to surprise. Through the official NASA images, the boundary between what is known and what is possible seemed to dissolve. The object hovered in that liminal space between familiar and alien, a bridge between the science we know and the mysteries still waiting to be uncovered. The more scientists studied 3I Atlas, the less it resembled anything they could name, standing as a silent testament to the infinite diversity of creation. An object balanced delicately between comet and something else when the first verified data of 3I Atlas reached NASA's scientific review panels. One comparison immediately dominated every discussion: Oumuamua. The two interstellar visitors, separated by years of discovery but bound by their alien origins, became twin chapters in a cosmic story that humanity is only beginning to understand. Oumuamua, the first confirmed interstellar object, had arrived in 2017 like a mystery from the stars, silent, fast, and gone before scientists could properly study it. It had changed the way we think about what drifts between the stars. And now, with the arrival of 3I Atlas, that legacy was reborn, refracted through the lens of better technology, deeper curiosity, and new questions that challenge everything we thought we knew about interstellar travelers. Where Oumuamua had given us a glimpse, 3I Atlas was giving us a revelation. The parallels between the two are striking but deceptive. Both came from beyond the sun's gravitational reach. Both followed hyperbolic trajectories that confirmed their origins from outside the solar system. And both captured the world's imagination with their strangeness. Yet beneath those similarities lay profound differences that tell a story of two entirely separate worlds, two objects born in vastly different cosmic environments, shaped by forces and histories that could not be more distinct. Oumuamua had been a ghostly enigma, reflecting sunlight in erratic flashes, with no visible coma or tail to mark it as a comet. 3I Atlas, by contrast, carried a faint halo, hinting at hidden volatile materials beneath its fractured shell. Where Oumuamua was smooth and silent, 3I Atlas was jagged and restless, its faint vapor trails whispering of trapped ices and internal motion. When scientists re-examined Oumuamua's archive data alongside the new images of 3I Atlas, one realization emerged: the universe does not craft interstellar objects according to a single recipe. Oumuamua, long thought to be either an asteroid-like shard or a comet without a visible tail, had exhibited a small but measurable acceleration as it exited the solar system. This had sparked wild theories ranging from exotic outgassing mechanisms to even the possibility of artificial propulsion. But 3I Atlas showed none of that behavior. Its motion followed a clean, predictable curve, influenced only by gravity. There were no unexplained accelerations, no sudden velocity changes. It was as if Oumuamua had been a question, and 3I Atlas was a kind of answer, one that replaced speculation with substance, mystery with material evidence. But at the cost of new ambiguities, the physical forms of the two objects also spoke of different origins. Oumuamua's light curve had suggested a highly elongated shape, possibly 10 times longer than it was wide, spinning chaotically as it traveled. It was, as one astronomer described it, a cosmic splinter. 3I Atlas, on the other hand, appeared more compact, its uneven, multifaceted body producing reflections that changed from smooth to sharp with each rotation. If Oumuamua was a shard, 3I Atlas was a sculpture, rough, intricate, layered with history. Radar analysis hinted that it might even consist of two bodies joined loosely together, forming a binary nucleus. This duality, if confirmed, would make it a unique interstellar relic, unlike any known object in our solar system. Yet the differences between the two go deeper than structure, they extend to chemistry itself. Spectroscopic readings of Oumuamua had been frustratingly inconclusive. Its brightness was too low, its passage too fast for detailed analysis. But 3I Atlas lingered long enough, and shone bright enough, for instruments like the James Webb Space Telescope to dissect its light. The resulting data showed the presence of materials that bore no resemblance to anything found on Oumuamua. While the earlier object had reflected neutral, reddish tones, consistent with cosmic weathering, 3I Atlas glimmered in a spectrum of silvers, violets, and pale greens. These hues corresponded to mineral and molecular compositions not typical of carbon-rich bodies, suggesting silicates, metallic oxides, and possibly exotic carbon compounds shaped by intense stellar radiation. The contrast was so stark that some researchers proposed the two objects had originated from completely different stellar populations, Oumuamua perhaps from a metal-poor system, and 3I Atlas from 1 enriched by heavier elements and volatile gases. Their behavior under sunlight also drew attention. Oumuamua had no visible activity. It neither vented gas nor shed dust. It reflected light in a way that seemed too bright for an asteroid, yet too inert for a comet. In contrast, 3I Atlas displayed subtle jets, faint bursts of vapor from fractures on its surface. This was the first sign of genuine cometary behavior ever observed in an interstellar object. The discovery confirmed that at least some of these visitors carry volatile compounds similar to those in our solar system, meaning that the processes that build comets' accretion, freezing, and radiation exposure are universal. Yet, even with its comet-like features, 3I Atlas behaved oddly. Its outgassing was uneven, sometimes occurring in shaded regions rather than on the sunlit side. This contradicted every known model of thermal-driven sublimation, leaving scientists to wonder whether its internal composition contained reactive materials that responded differently to heat. In comparing the two objects, another revelation emerged. 3I Atlas was far more massive. Estimates placed it at several hundred meters across, possibly even larger, while Oumuamua was likely less than 200 meters long. This difference in size not only affected their brightness, but also their potential for survival during interstellar travel. Oumuamua's fragile shape might explain its rapid spin and odd motion. It was a smaller, lightweight remnant, buffeted by radiation and gravitational encounters. 3I Atlas, heavier and denser, were the marks of endurance, a voyager that had survived cosmic collisions and radiation storms without disintegrating. Its thick outer crust, rich in complex minerals, may have acted as armor against eons of cosmic exposure. The contrast painted two portraits of survival: Oumuamua, fleeting and fragile, and 3I Atlas, ancient and enduring. What truly fascinated scientists, however, was how these two interstellar objects illuminated the diversity of planetary formation across the galaxy. Each carried with it a chemical signature of its birthplace, encoded in its molecular makeup. By studying them, NASA and the international scientific community could glimpse the variety of conditions under which worlds form. Oumuamua, barren and inert, might have come from a region stripped of volatiles, perhaps from the inner system of a dying star. 3I Atlas, rich in ices and metals, likely hailed from a system still young when it was ejected, a place where comets and planets were still coalescing. Together, they suggested that interstellar space is filled with debris from countless worlds, each fragment telling a story of creation, destruction, and exile. For astronomers, the comparison between Oumuamua and 3I Atlas was not merely academic. It represented a profound shift in how we understand cosmic migration. Before 2017, the idea of detecting interstellar debris within our solar system was little more than theory. Now, with two confirmed examples, the galaxy suddenly seemed more connected, more alive with motion. The realization that material from other star systems regularly drifts through our neighborhood opened a new field of study: interstellar archaeology, the science of reconstructing alien histories from wandering fragments. Each visitor offers a snapshot of another world's chemistry, another sun's influence, another chapter in the story of the Milky Way's vast and restless evolution. The emotional response to these discoveries was as profound as the scientific one. When the public saw the side-by-side comparison images, Oumuamua's faint, stretched silhouette, and 3I Atlas's fractured brilliance, they were seeing, in essence, a portrait of cosmic diversity. Two travelers, each bearing the signature of a distant home, converging briefly within our solar system before continuing on their eternal paths. For the scientists who had devoted years to tracking them, these images were reminders that the universe is not a static expanse, but a living, dynamic sea of exchange. Matter moves between stars, fragments of alien worlds cross our skies, and each encounter reminds us that we are part of a larger galactic story folding quietly beyond the horizon of time. In many ways, the tale of Oumuamua and 3I Atlas is a reflection of humanity's growing awareness of its place in the universe. These interstellar visitors are not anomalies. They are evidence of a connected galaxy, a cosmic web where the boundaries between systems are porous and alive. Oumuamua came as a whisper, fleeting and strange, like a question we could not answer. 3i Atlas arrived as a revelation, solid, detailed, and mesmerizing, a fragment of an unknown world, showing us that the galaxy is filled with wonders still waiting to be found. When the first official 3i Atlas images were unveiled to the public, what followed was more than just a wave of scientific excitement, it was an awakening of imagination across the globe. The photographs captured something that transcended typical astronomical documentation. They were haunting, ethereal, and strangely emotional, like visions of an ancient relic drifting through the emptiness of time. For scientists, these images represented a treasure trove of data, each pixel holding clues about composition, origin, and evolution. But for artists, writers, and dreamers, they looked like something pulled from a dreamscape, proof that the universe could still astonish even the most disciplined minds. And in that overlap between reason and wonder, science met imagination in its purest form. Many at NASA's Jet Propulsion Laboratory, seeing the refined 3i Atlas imagery for the first time, felt surreal. After months of calibration, filtering, and correction, the object's final composite image revealed an intricate texture that defied comparison. The surface was rough yet luminous, fractured but symmetrical in its decay, like the face of a world that had witnessed both creation and catastrophe. Its faint tail shimmered like a ghostly filament, twisting gently as solar wind sculpted its icy emissions. The object's body reflected sunlight in gradients of blue, silver, and burnt orange, a palette rarely seen in celestial photography. These color variations hinted at minerals and metallic deposits uncommon in solar system comets. But what fascinated everyone most was how alive it appeared. Like a living fragment caught mid-transformation, astronomers began to publish detailed analyses, explaining the spectral fingerprints and light-scattering patterns that gave rise to such beauty. But beyond the math and data tables, even they found themselves slipping into poetry. Dr. Rena Vasquez, a lead researcher on NASA's Deep Space Observation team, described it as a silent traveler wearing the history of another sun. Her words spread quickly online, turning scientific observation into metaphor. The images of 3i Atlas didn't just expand knowledge, they expanded feeling. The boundaries between scientific curiosity and artistic interpretation blurred, creating a shared language of awe. Across social media and academic forums, debates erupted, not just about the physics of the object, but the meaning behind its presence. Was it a message from the cosmos? A natural sculpture shaped by forces we could barely imagine? Or perhaps just another piece of debris, a profound only by human perspective? Artists began rendering digital interpretations of the images, amplifying details that telescopes could only hint at. The public saw paintings, animations, and 3D models depicting 3i Atlas as a radiant shard of lost matter gliding through infinite darkness. These works captured something science alone could not quantify: the emotional magnitude of realizing that we are witnessing material from a world that no longer exists. Writers and philosophers, too, joined the chorus of curiosity. The sight of 3i Atlas reignited an ancient tension between rational understanding and imaginative wonder. For centuries, humanity has oscillated between these two poles: the analytical desire to measure the cosmos and the poetic need to feel its mystery. In the past, discoveries like Galileo's moons of Jupiter or Hubble's deep field galaxies bridged that divide. But 3i Atlas reignited it in a modern context. It became a symbol of how science, at its highest level, is not separate from imagination, but dependent on it. Every hypothesis, every leap of understanding, begins as an act of creative vision, a willingness to imagine what cannot yet be proven. Within weeks of NASA's image release, a series of documentaries and podcasts began exploring the aesthetic impact of 3i Atlas. One popular program, Cosmic Frame, featured scientists and visual artists side by side, discussing how the interplay of data and design shapes public understanding of space. The show's host described 3i Atlas as a cosmic Rorschach, a mirror that reflected not just light, but human emotion. The object's strange symmetry and fractured glow seemed to evoke themes of loss, endurance, and rebirth. Listeners commented that looking at it felt like looking into the past, a fragment of a world that had died long before ours began. For researchers, this emotional response was both surprising and enlightening. They realized that scientific imagery had crossed a cultural threshold. It was no longer just about data dissemination, it had become a form of storytelling. The instruments that captured 3i Atlas, from the Hubble Space Telescope to the James Webb, were not merely machines, but storytellers of light. The photographs they produced were chapters of an epic being written in photons, spanning billions of years and countless light years. Through this lens, even the driest datasets began to feel poetic. Every spectrographic peak became a heartbeat, every reflection angle a memory frozen in ice. At universities and public exhibitions, scientists found themselves speaking not only of measurements, but of meaning. When the European Space Agency released their enhanced visualizations, audiences gasped not at the technical data, but at the visual majesty of the images. People described feelings of smallness and wonder, the same emotions that drive both art and science forward. Children asked if the comet could be seen by eye. Poets wrote verses inspired by its shimmering form, and digital creators transformed it into visual symphonies of light and sound. It was as though the boundary between empirical truth and emotional truth had dissolved. The fusion of science and imagination reached an even deeper layer when astrophysicists began to speculate about the origins of 3i Atlas using computer-generated simulations. These simulations, rendered with breathtaking realism, reimagined the object's birth around an alien star system. They depicted a turbulent world torn apart by gravitational tides, with fragments like 3i Atlas cast into the void. Watching these reconstructions felt like witnessing mythology rendered in physics. For viewers, it wasn't just data visualization, it was cosmic storytelling. The universe, vast and indifferent, suddenly felt intimate again, like a living organism telling us its story through motion and light. Psychologists studying the public reaction noted that the fascination with 3i Atlas revealed something fundamental about human nature. We are pattern seekers and dream builders. When we look at an object like 3i Atlas, we don't just see ice and dust, we see a reflection of ourselves, of our own impermanence and resilience. The interplay of logic and imagination that defined the discussion around 3i Atlas proved that science is not sterile, but profoundly human. It thrives on curiosity, wonder, and the drive to transform the unknown into meaning. Educators quickly recognized the power of this moment. In classrooms across the United States, the 3i Atlas images became a tool for teaching both science and art. Teachers encouraged students to describe the object scientifically and then to imagine its journey artistically. It became a bridge between disciplines, a way to show that understanding the universe requires both precision and passion. Students wrote stories, painted cosmic landscapes, and even composed music inspired by its slow celestial drift. In this way, 3i Atlas became more than an object of study, it became a muse. In professional circles, scientists began to embrace the creative dimension of their work more openly. They realized that imagination is not the opposite of science, but its engine. Every new model of interstellar formation, every theory of cometary behavior, begins as a speculative vision. To look at 3i Atlas and wonder what it is without yet knowing is to participate in the essence of scientific discovery. The image of this interstellar traveler, gleaming like a memory in motion, reminded everyone that curiosity is not a luxury, but a necessity. Without imagination, the universe remains invisible. In the end, the story of 3i Atlas is not confined to laboratories or observatories, it lives in the shared imagination of a species that dreams with open eyes. The object may be cold and distant, but in its reflection, humanity found warmth and meaning. It showed that data can be beautiful, that facts can inspire wonder, and that the space between science and imagination is not a boundary, but a bridge connecting our deepest instincts to our highest understanding. When the new 3i Atlas images began to circulate across the world, they did more than simply capture the features of an interstellar object. They reflected something far more intimate: us. The object, gliding through the solar system after eons in the void, became a mirror in which humanity saw both its insignificance and its brilliance. Every shimmering fracture and faint emission in those NASA images seemed to whisper about our own search for meaning in a cosmos that often feels silent. The fascination that swept across scientists, artists, and ordinary dreamers alike was not just about what 3i Atlas was made of, but what it made us feel. In its lonely trajectory through the dark, we recognized a story we've been telling ourselves for centuries, a story of curiosity, exile, and longing to understand where we belong. To gaze upon 3i Atlas was to be reminded that we are travelers too. Our species, clinging to a small blue world orbiting an ordinary star, has always looked outward with a sense of wonder mixed with yearning. The images of this interstellar visitor arriving uninvited into our cosmic neighborhood carried an emotional resonance that transcended science. It came from somewhere beyond, somewhere unknown, and for a brief moment, its path intersected ours. That moment, fleeting as it was, reflected the way we move through existence, each life, a short orbit within the greater dance of the universe. The idea that 3i Atlas could have originated near a distant star system billions of years ago, only to drift aimlessly until captured by our telescopes, stirred a sense of kinship. It was as though we were witnessing an echo from another civilization's past, a fragment of a story that no one remembered, but everyone could feel. In classrooms and observatories across the United States, scientists began using 3i Atlas as a metaphor for human exploration. They spoke of it not only as a scientific curiosity, but as a symbol of resilience. Like the object itself, humanity has survived collisions, chaos, and countless near extinctions. We too are shaped by cosmic forces: time, gravity, chance, and yet we endure. The dust and ice on 3i Atlas's surface became a reflection of our own layered history. Just as its outer crust bore the scars of its journey, so does humanity carry the marks of its evolution: wars, discoveries, dreams, and failures etched into our collective identity. Through the lens of a telescope, we were not merely observing an object, we were, in a sense, observing ourselves. The emotional reaction from the public revealed something profound about human psychology. When people saw those official images, with their surreal glimmers of color and light, many described feeling both awe and loneliness. They weren't responding just to the science, they were responding to the symbolism. Here was a visitor from the infinite unknown, wandering through our home before continuing into the void. It mirrored the universal human experience of transience. Just as 3i Atlas would never stay, we too move through the universe temporarily, leaving behind traces of existence before fading back into cosmic silence. The beauty of that truth resonated deeply. It reminded us that impermanence is not tragedy, but poetry, the essence of what makes us aware, conscious, and alive. Philosophers and cultural commentators began to frame 3i Atlas as an emblem of cosmic perspective. Carl Sagan once spoke of Earth as a pale blue dot, a fragile oasis in a vast dark sea. Now, decades later, 3i Atlas became a new symbol for that same humility. Its silent passage reminded us that the universe does not revolve around human drama. We are, in cosmic terms, brief and small. Yet in that smallness lies something extraordinary: awareness. We are the universe looking back at itself, capable of understanding what it sees. Every image of 3i Atlas carried that realization. It wasn't just a comet, it was a mirror through which the cosmos recognized its own consciousness. Reflected in human curiosity, psychologists studying public reactions noticed that discussions about 3i Atlas often turned inward. People began sharing reflections on existence, mortality, and meaning. The object became a kind of shared meditation, prompt for cosmic introspection. In the stillness of space, it invited questions that transcend time. Where did we come from? Why are we here? Are we alone? For generations, humanity has looked to the stars for answers. But perhaps the greatest answer lies in the act of looking itself. The awe we feel when confronted with the unknown is proof that we are part of something larger. That capacity for wonder is the bridge between the cold indifference of the cosmos and the warmth of human emotion. In a sense, 3i Atlas reminded us that discovery is not just about finding new things, it's about rediscovering ourselves. Each telescope image, each spectral reading, is a dialogue between humanity and the universe. When scientists decoded the light signatures reflected from its surface, they were reading a message written in the oldest language there is, light itself. And that light, traveling for billions of years before meeting our instruments, seemed to say that even across unimaginable distances, connection is possible. In studying 3i Atlas, we realize that knowledge is a form of intimacy. The very act of observation is an embrace across the stars. There's a quiet poetry in how our civilization responded to these images. Some saw them as reminders of our vulnerability, others as proof of our potential. In an age dominated by technology and distraction, 3i Atlas became a rare moment of collective stillness. For a few days, the world stopped scrolling and simply looked upward. People who had never before cared about astronomy found themselves drawn to its beauty. The object's delicate glow, captured against the backdrop of infinite night, rekindled something primal, a sense of belonging to the cosmos. It reminded everyone that we are not separate from the universe, but expressions of it. The same carbon, oxygen, and metals found in 3i Atlas flow through our blood and bones. We are, quite literally, made of the same cosmic material. As the final images of 3i Atlas settle into the archives of human discovery, they leave behind something far greater than data or documentation. They leave a feeling that the universe is both larger and more intimate than we ever dared to imagine. The official images released by NASA are not just glimpses of a cold, distant traveler. They are mirrors reflecting our own desire to explore, to understand, and to belong to something vast and timeless. In those swirling shadows of cosmic ice and dust, we see a reflection of ourselves, fragile, fleeting, yet endlessly curious. 3i Atlas, like the interstellar objects before it, reminds us that our solar system is not isolated, but connected to a greater galactic web, where fragments of other worlds drift silently through the darkness. These travelers are more than cosmic debris. They are messengers of history, carrying whispers of creation across the stars. They tell us that the boundaries we draw between here and there, between known and unknown, are illusions shaped by our limited view. The universe does not stop at the edge of our understanding. It continues, endlessly and beautifully, inviting us to follow. This is what makes the new official images of 3i Atlas so profoundly moving. They reveal not only the outer world, but the inner one, the landscape of the human spirit. Each pixel of that distant glow carries centuries of human longing, every calculation and photograph echoing the same question our ancestors once asked when they first looked at the stars: what else is out there? In that question lies the essence of who we are. We are a species built on curiosity, driven by wonder, and defined by the pursuit of the unknown. Science gives us the means to measure the cosmos, but imagination gives us the reason to look. Together, they form a kind of cosmic heartbeat, a rhythm that pushes us to keep reaching, even when the answers seem impossibly far away. The 3i Atlas images have reignited that rhythm. They have reminded us that every discovery is also an invitation, every mystery a door waiting to open. And though the object itself will fade into the endless dark, the light it left in human consciousness will not. We may never know where 3i Atlas truly came from or where it will go next, but that uncertainty is part of its beauty. It drifts, as we all do, across vast distances, guided by invisible forces, carrying stories too ancient to tell. Its brief visit was a reminder that even the smallest presence can reshape our understanding of everything. Somewhere in its icy heart may lie the ingredients of life, or the remnants of a forgotten system. Somewhere in its passing, humanity found itself once more in awe of creation's boundless scope. So tonight, as you drift into sleep under the same sky that once held 3i Atlas, Remember that this moment in history is part of something greater, a cosmic conversation, still unfolding. The universe speaks in silence, in light, in motion, and in mystery. And we, fragile yet determined, are learning to listen. The story of 3i Atlas will not end with its disappearance. It will live on in every dream, every telescope turned upward, every child who looks to the stars and dares to wonder what might be beyond. Because in the end, the greatest discovery is not out there among the galaxies, it's within us. It's the realization that we were always meant to look up, to search, to imagine, and to believe that somewhere beyond the stars, there's more waiting to be found.